Evaporation, distillation, and crystallization processes have always been an inherent part of process engineering. Heat exchangers, which apply energy from water vapor, are often employed on a large industrial scale. To understand how an MVR fan is able to minimize the amount of energy such systems need, let's first take a look at the evaporation process on this falling film evaporator as an example. To separate the product to be concentrated from other constituents in the water, energy must first be applied. This takes place in the heater chamber. The medium to be evaporated is introduced into the evaporator intake and spreads over a distributor plate onto the tube bundle. From here, it runs down against the inner walls of the tubes as a thin film under surface tension and gravitation. The medium is heated up by introducing water vapor into the heater chamber. It condenses on the outer walls of the tube bundle and transfers its thermal energy onto the tube. The liquid on the inside of the tube bundle absorbs this heat and starts to boil. Parts of the product separate in the form of water vapor, and the product concentrates along the tube. At the lower end of the tube bundle, the concentrated product enters the so-called precipitator. This is where the vapor that develops is separated from the concentrate. The concentrate drops down and collects in the dished boiler head. From here, it's pumped out for further processing. Water vapor that is at a lower temperature than the heating steam fed to the system is left behind. In the conventional evaporation process, the heating steam is generated in a steam boiler. This is an energy-intensive process because as the water is transformed into vapor, it absorbs a high amount of energy and has to be brought up to the required temperature as well. How can we increase the temperature of the existing vapor so that it can be reused? By using the fans for mechanical vapor recompression from TLT-Turbo. The vapor that develops is recompressed in the fan. As a result, its temperature is increased to such an extent that it can be reused in the evaporator as heating steam. The electrical energy fed in is used only to increase the temperature of the existing vapor, not to generate it. This closes the loop, and the steam boiler can be switched off once the system has started up. Cooling the vapor by injecting water at the fan inlet prevents it from overheating during the compression process and ensures it leaves the fan in the saturated state. Surplus water collects in the fan housing and is discharged through the automatic condensate drain, which is a standard feature on TLT turbo fans. TLT turbo fans are supplied on a base frame and can be installed and commissioned with minimum effort. This is thanks to the impressively simple system design. Let's take a look at some key components. The fans are most commonly driven by electric motors that can reach speeds of up to 6,500 revolutions per minute. One key component of the solution TLT Turbo developed is the practically maintenance-free bearing assembly. The assembly incorporates heavy-duty ceramic hybrid bearings, which has several benefits over conventional bearings in this application. Because this special material pairing of ceramic and steel undergoes less friction, heat development and wear in the bearing are reduced considerably. The result is a longer service life compared to conventional bearings. The bearing's high rigidity permits very high speeds during subcritical operation. This means that the fan does not have to pass through the first critical speed at startup. This has made dampening in the bearing superfluous. There's no need for an oil system at all. The bearing is lubricated with grease and requires very little maintenance. The bearing systems have a service life of at least 10 years, and this can be notably extended by the application of an automatic grease cartridge, which is easy to install every few years. To cool the bearing, TLT Turbo uses a passive cooling system comprised of a cooling disc on the shaft and, if necessary, additional cooling fins on the bearing housing. The bearing temperature and vibration values are continuously monitored by sensors to ensure that any irregularities are detected at an early stage. The bearing's outstanding running properties, even in case of inadequate lubrication, means that service and maintenance measures can be suitably planned and coordinated with the maintenance intervals of the system. The TLT Turbo MVR design is set apart from other products on the market by its impressively high availability, outstanding efficiency, And because there is no oil system, much lower maintenance costs. For over 145 years now, TLT Turbo has stood for innovation, reliability, and solid, competent collaboration. Customers all around the world trust in this expertise.